Hey there guys, and welcome to another day of doing NeetCode. Today we're going to be continuing with stack. I'm not really a big fan, but we're going to be doing stack. We'll do the one we didn't do, turn our parentheses, and I'll be honest, I have absolutely no idea how to do this. I know it's supposed to use stack somehow, but what we're going to try instead is we're just going to watch the explanation video.
Hey everyone, welcome back, and
we're just going to try and figure out how to do it off that.
write some more neat code today. So you want them to be nested in a valid way, right? Like we can't have a right parenthesis come before free after it, right? Of parentheses, three are going to be open parentheses, and three are going to be closed parentheses, right?
So already off the rip, that's pretty good information, right? Whatever n is, n equals number of opened, number of closed. Okay, I feel we can use that.
So this is a open parenthesis, this is a close way out the backtracking solution, kind of, right? Like a sort of brute force approach. How would we even do a brute force approach? Let's say n equals 3, so then we have 3 parentheses. What does that tell us about valid parentheses, right? Like this is one valid parenthesis that satisfies this condition, right? We have 3 open parentheses, 3 closing parentheses. Well, the first thing it tells us is that we need 3 open parentheses and 3 closing parentheses, right? That much is pretty obvious, right? Like you could probably figure that out by yourself. If we have 3 pairs, then we definitely need 3 open and 3 closing parentheses. So in total, 6 parentheses. But what about the order of parentheses? So let's say so far I'm empty, right? We're empty. Can I start out with an open parenthesis? Yes, I can, right? But can I start out with a closing parenthesis? No, we know that
another thing then is that, so n is the number of open and the number of closed, right? The number of closed has to be less than or equal to the number of open. Okay, like already in the list.
This is
like if I open 1, then I can only have 1 closed, but if I open 2, then I can have 1 or I can have 2.
Valid. No matter what I do now, this is always going to mess up our parentheses. So we can't start with a closing parenthesis. We can only start with an open parenthesis. Okay, but now let's say I have 1 open parenthesis. Now what can I do? Can I have another open parenthesis?
Yeah.
Yup, because our limit is 3 open parentheses, and so far we have 2, so we're allowed to do that. What about a closing parenthesis? Can I have a closing parenthesis? Yes, because so far our open count is 1, and initially the closing count is 0, and I can, by adding this parenthesis, I'm just changing the closing count to 1 now, parenthesis, yet 1, so I'm allowed to add a open parenthesis. What about a closing parenthesis? Can I add a closing parenthesis right now? No. Of close parenthesis, this closing parenthesis will never have a matching open parenthesis on the left of it, so we can't add this parenthesis. And how would you figure that out from code? Well, just take a look at the count we have so far. Before we add the parenthesis, we have a count of 1 for closed, we have a count of 1 for open. Basically, what this tells us is that we can only add a closing parenthesis if the count of closing parentheses is less than the open count. We can only...
Yeah, let's pretend I put that
if this is true, are we allowed to add a closing parenthesis? So if, for example, if I were to add another opening parenthesis, now we update our open count to 2. So now we have 2 open parentheses, right? So 2 is open, 1 is closed from over here, right? So now I'm allowed to add a closing parenthesis, right? So basically, let's say if we're going to do backtracking, these are the 2 rules that we have to follow. This is basically our base case. Once we have 3 open and 3 closing parentheses, then we have a valid parenthesis formation, right?
So that's gonna be
and
like a while.
this condition tells us when we're allowed to add closing parentheses, we can add as many open parentheses as we want as long as it's under the limit, which is n, right? We can add up to 3 open parentheses, but we can only add a closing parenthesis
Like, I
if
can
the
make something to add to make one string, but I don't know
number
if I
of closings so far is less than the number of open parentheses. So with that said, let's start our backtracking solution. So far we're empty, right? So the first thing we're gonna do is add a open parenthesis. So now this is what that means is close. Okay, let's take a look at and from right. We have one open limit. So we're gonna have 3 that we have two choices with two choices because we see we have 2 open open 3 open close. So see we have open and also closing close and parenthesis, and since this has 3 open 3 and 2 close, we know that we need 3. This is we are going to add 2 closing parenthesis, and lastly this one we're also adding a single closing valid, right? So these 5 are going to be returned as our result. These are the 5 ways we can make valid parentheses. So now let's finally write the code. This is basically what we're going to do.
Okay. So that makes sense. Like, but I don't know how we're going to write that code. Because we could try. Ooh. Tree maze. So we have not done no trees. Let's think. We have to backtrack something, right? So res is probably a list, right? And then I guess we gotta do a function that does everything. So if I could have function like def backtrack, and I will open a num open, num close, right? And I said, okay, so if we need a stack as well. Like, I have no idea how we're gonna use stack in this. Res is the list, so we're just gonna do like a let's look at a little bit about what he does.
Hey everyone, welcome back. So now we're on n. We're only gonna which is gonna equal n. So I'm gonna do this recursively because that's and see
so stack res,
inside.
And they do a backtrack function with the open close. Okay. Okay. So let's think about this, right? We have the same thing. So what he does start as true, right? If num open equals num close equals n, return something. Or res.append stack, and then when we're done the function here, we'll return stack. Okay, that's a cook. So if let's do if num close is less than num open and num open is less than n, then we do stack dot append. Oh, like stack dot append open thing. And then we have to do something. And once we put it in, we send it back to the function with num open +1 and num close. And then we do the same thing with the other one. If num else, I guess it's just else statement. Else. No, elif. Num close is a. If num open. No, this one should be num close +1. And then for num open. If num open is less than boom, there you go. And then I think we have to delete the numbers, so we'll like hit a quick pop, see what happens when we do this. We did nothing. Cold. Stack.append, put it in backtrack. No, this makes sense. Because I append something, right? So if equals something equals n, right? Just like you did. I res.append stack. So for example, we start up, right? Num close less than num open. And num close, I don't need that. If num close is less than num open, we stack that append a closing bracket, and then add num close +1. If it's not, if num open is less than n, we stack that append this one, send it back here. So it'll go like here, like for example, right? It'll go this one, then 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 it'll return, then it'll get out of this function, and it'll go pop, 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 pop. Oh, it can do it again. Oh, return stack, I might return res. Let's keep watching.
So in that case, we have do is in our base case. Remember, if we
res.append. Okay. Boom boom dot join stack. Cool. And return.
want to add a open parenthesis, we have to
return. Alright.
check that our open count is less than n. If that's true, what we can do is to our stack, we can append a open parenthesis.
Okay.
So just an open parenthesis, and then we can recursively continue our backtrack. But if we do that, we have to increment our open
Wait, if this works, then we don't need the video. Okay, we need the video.
count by 1, and the closed count remains the same. And after that backtracking returns, though, we do have to update our stack because we only have a single stack variable. Remember, we're not passing the stack into every single call. Function, our recursive backtrack, except
They did the
by
same
function.
thing.
So you can see we
Oh, I never called the function. If I go backtrack 0, 0, let's keep it as elif, right? I want to see if it works. But if I just do if statement, it worked for both. It's actually because it's the same code. Okay, so this one we used a bit of the solution, but I guess I'm kind of understanding stack a bit more. It's pretty smart. I understand the solution very well. We go through. It does this one, and then it'll do this one. So it'll go through, and at the start it'll add one of these, and then it'll go through, and it'll add one of these, alright? And then it'll keep going, and it'll add one of these. Like the way it works is it'll go like this. Like it'll go, let's go open bracket, open close, open close open, open close open close. We'll just say it's 4, and then after it'll be okay. We'll go back to this one, and we'll this one finished, so we'll return this one. And then we'll return this one, and then this one will go and it'll go open. No, and it'll return all the way here, and then it'll go all the way to the next one. And instead of going into this one, it'll go into this one. So it'll go open, open, and then open, open, close, and then open, open, close, close, and then it'll do all the way return again, and it'll go back into this one. Like it'll go into this one. It'll go into this one first, over here, and then it'll go into this if statement before this one. So that's why it'll always try and close it, and if it can't close it, or if it already did close it, it'll open it again. So then over here, right, we open 2, and then the next one was to put a close here, and then when we return it, we've already put a close, so we'll open it again, so we'll go open, open, open. This is genius. I guess the stack is very smart too, to keep track, and then you pop it afterwards to get rid of it. Okay, we'll try and use this into the next one that we'll do probably tomorrow. Car fleet, which this doesn't look interesting at all. But yeah, I'll see you guys tomorrow.